we have some exercises here. These are going to test you a little bit more in your understanding of mole and the role that mole has with AMU and grams. And so it just wants you to try this without using any calculation, just using a little bit of understanding. And so it says, what is the mass in grams of this number of hydrogen atoms? Well, if you look at the periodic table, you're going to see that hydrogen has an AMU roughly around 1. That is the same thing as saying, okay, so one hydrogen will roughly have the weight of 1 AMU, but it also means that 1 mole, which is this number right here, will be 1 gram. 1 mole of hydrogen will be 1 gram. And so it also wants you to define isotopes, which we have done before. That is the same element, and the same element is always going to have the same amount of protons. What varies is the amount of neutrons. And so the difference between these two chloride atoms right here is not the amount of protons, that is the same, but amount of neutrons. So we can see here that this atom right here will have 2 neutrons more than this one. And looking at, again, the average mass, we're looking about, if you look at all of the boron atoms that we have on planet Krypton, 65.75% are going to be this isotope right here. And if you want to find the average mass, it is easier to use from model 2 that we looked a couple of videos ago, where we're not looking at the number of atoms, but the percentage, because that's what's given here. So if I take this mass right here, multiply it with 0.6575, add this number right here, multiply it by 0.2555, and then add this mass right here with 0.087. So I'm just turning these into an average, just calculating how many I'm going to have that of these atoms that weigh this much. So over 65% are going to weigh roughly 10, 25% is going to weigh roughly 11, and roughly 8 to 9% are going to be this weight right here. And the average, well, take the weight and multiply it with the percentage of how many you have, add them all together, and you're going to get 100%. And therefore, an average weight that's probably going to land somewhere around 10, as this is the most abundant isotope. And as you scroll down further here, you're also going to see there are different types of questions where we're looking at isotopes and mass. So you use the same methods as we used before.